All right, guys, so let's see. There we go. All right. Okay. Add that person in. Okay, guys. Well, good afternoon. And we will be working today on, as you can see, unit rates and ratios of fractions. Now, remember that ratios, while they appear like fractions, they are not fractions, okay? So this is really important that we remember this, that these are not the same. So when we are working on these, we need to remember that they are different. For example, we were always taught that fractions had to be, they had to look like this. They had to have um, uh, whole numbers, right? You could have an integer there, so you could have like a -1. But anything that looked like this, if you tried to present this to your teacher when you were working on fractions before, you'd be in a lot of trouble, right? Because they want to know why you weren't paying attention in class enough to know that you can't put fractions in a fraction, right? But this isn't a fraction. This is a ratio that says 1/3 to 3/4. Okay. Now, we're going to learn today how we can do problems that look like this. Okay. Now, the math is not really that difficult. The math is actually pretty simple. After you do about one of these, you're going to be like, that's it? And I'll be like, yeah, that's it. And you'll be like, well, dude, that's like totally easy. Why couldn't we have done that last week? That would have been more pleasant than what you made us do last week, right? But it's okay. We'll just tough it out. All right. So let's look at this first problem and let's get started. So here's our problem. If 1/3 of a gallon of paint covers 1/9 of a gate, then how many gallons of paint are needed to cover the entire gate? Okay, now that sounds a little scary right now. How many people think that sounds a little scary right now as you're looking at it? Okay, but I think you know that when we cover this stuff, it doesn't end up being scary, does it? It ends up being pretty simple. You just have to understand how the math works. So let's go back through. We're going to read it again. We're trying to find out how much paint. So if 1/3 gallon covers 1/9 of a gate, so number of gallons for cover one gate. So basically what I'm saying is, if it took him 1/3 of a gallon to paint 1/3 of the gate, how many gallons do I need to paint all of it together, right? So that's not really a tough question, right? It's more of a thing of how are we going to calculate that? Well, we're going to use ratios and we're going to use proportions, all right? So I'm going to say 1/3 gallons is to 1/9 of a gate as what? So do we have information on what might come over here as, wait a minute, let me step back a moment. You remember working with unit rates last semester? Remember we had unit rates where I said like they drove 550 miles in 8 hours, and we had to figure out how many miles per hour they drove on average, right? So this is a unit rate. So we ended up dividing the top number by 8, and that told us the average of how many miles they drove every hour, right? So this is, if we want to get this to a unit rate, the gate is the one we want to get to number 1, right? So this is going to be our unit, is 1 gate, which I know sounds ridiculous. Oh, I'd like to know the ratio of something to 1 gate. Well, what's one gate? Well, in this case, it's this gate. Well, which gate? Well, that gate. Which one gate are you talking about? The gate I was telling you about. Well, which gate is that? The one in my backyard. Well, how am I supposed to know what the gate in your backyard looks like? You don't need to know what the gate in my backyard looks like. You just need to know that it takes this much. Why are we talking about your gate? Oh, shut up. Just look at the problem. You know how people can be, right? So basically what I'm saying is I want 1/3 divided by 1/9, right? So let's take a look at that. 1/3 divided by 1/9. Now, do you remember the trick when we're dividing fractions? What's the rule? What's the understanding in math about how we divide fractions? Do you remember the code? There was a 3-letter code that reminded us how to do this work. I think Audrey has it. She got a little smile on her face like, oh, I remember that. It's keep, change, flip, right? I forgot to pull that chat up so I can see it properly. Right, exactly, Lucia. Very nice. So I'm going to write it down here for clarity. So I keep the first one, I change the sign, and I flip the second fraction. So now I have 9/3. What does 9/3 equal?
Six.
No, that would be 9 minus 3. Carol Ann?
3.
Yeah, because this is, remember that the fraction bar means division. Okay, so 9 divided by 3 is going to be 3. And the units that we were asking for the answer was gallons, right? So my answer is going to be 3 gallons. Yeah? Not really a tough problem, right? Now, I want to show you how they, let's look at how they solved it. Because I think it's always interesting to see how other people look at it. And so here we go. So they did it the same way. Divide the total amount of paint by the portion of gate that was covered, right? Because so they did our 1/3 divided by 1/9. And we're doing a fractional division problem, which means we write 9 as an improper fraction, we flip it over, and we turn the division problem into a multiplication problem by multiplying by the reciprocal. Boom. And so they got the answer exactly the same way we did, didn't they? All right. Now, let's take a look at the second page that we have. Now, let's take a look at this one. Uh-oh, we're talking about bananas again. Where's Dylan? Right? Was it Dylan, the guy in our previous worksheet that was being paid with like 70 bananas an hour? Like, dude, you need to reconsider your life choices, because I don't think getting paid in bananas is really the best option. Getting paid in chocolate, I might be willing to agree is a good choice, but I'm thinking getting paid in bananas doesn't work. Unless, of course, it's chocolate covered bananas, in which case I'd have to say that the chocolate covered bananas would be a better option. Be that as it may. All right. So let's look at this. Jackson eats 1/4 part of a banana in 1/2 minute. How much time will he need to eat the full banana? So 1/4 in 1/2 minute. So I'm going to say banana. And then how long for whole? So again, we're looking at a ratio, right? Now, here's the deal. Whenever you do these problems, you have to figure out what the unit is. So what information are they looking to find out? What do they want to know? Let's read it again. How much time will be required to eat one banana. So when we look at that, we realize that since that's going to be one banana, that's going to be our unit, right? So that's going to be the number that we want on the bottom. Does that make sense? Because when we're done, we want to have some amount of time to eat one banana, just like we had miles per hour before, right? Yeah, remember we did miles per hour? So because we want to get down to how many over 1 hour. So we're looking for our unit rate. So on this one, we're looking at how long for one whole banana. So we're looking to have bananas down here and minutes up here. Does that make sense? Do you think I've done that right? Time per banana, right? These are very interesting rates, I think, don't you? Well, actually, the average rate of banana consumption is actually 3.75 minutes per banana. We've done a science thing on this. I got a research grant of $500,000 to research the amount of time it takes to eat a banana. That's kind of like the Tootsie Pop commercial, right? How many licks does it take to get to the center of a Tootsie Pop? You could do a research study on that. Oh, an interesting aside. I remember when I was in college, I saw a little news item inside of a medical journal that said somebody had gotten a research grant of like $70,000. And what they did was they took a group of musicians and they took a group of non-musicians and they had them listen to different tones. And would you believe that the musicians were better able to distinguish between the two different tones than the non-musicians? So somehow musicians were better able to figure out tones and notes. It's like, wow, you needed $70,000 for that? Right. So when we started out, we had 1/2 minute per 1/4 banana, right? So now what are we going to do? Yeah, Andrew, you're fine. So now I'm going to do my division, right? Because the fraction bar means division, right? Fraction bar means division. So this is going to be 1/2 divided by 1/4, which is 1/2 times 4/1, right? What's that answer going to be now after we do the math there? Excellent, Sergio. This is going to give me 4/2. And when I do the division here, remember fraction bar means division, I'll get 2, and I have to say minutes, right, per banana. It makes me kind of chuckle to think that I'm giving an answer in terms of time and bananas. I don't know about you, but I think that's sort of comical. Maybe I just need to get a life, but I think that's kind of funny. Make sense, guys? Do you see how that one worked? Okay. Now let's take a look at number 2. Now, number 2 says Mike ran a 1/2 mile in each 1/7 of an hour. Compute the unit rate of miles per hour as the complex fraction. Okay, so I'm looking for miles per hour. So that means that I'm going to put miles on top and hours on the bottom, right? Because that's what a unit rate means. When I hear miles per hour, that tells me the order from top to bottom for a unit rate, correct? So now I'm going to put 1/2 miles and 1/7 hour, right? Now that we've done a few of these, do you know what I'm gonna end up with an answer? See if you can figure it out. Now we've done a few of these now. And you may be able to just like bang zoom right to the answer. Maybe not, but just thought. What would it be? That is correct, Sergio. Right? And I'm going to get 7/2 And Sergio was not happy with that, so he converted that to a decimal. 7/2 is okay, because you can say, so you can say 3.5 miles per hour. Or you could say 7/2 miles per hour. Both of those would be acceptable answers because both of those are mathematically accurate. Yeah? This making sense? Okay. Do I need to leave that there for a minute? I see it looks like some people are still writing. I'll leave it there for a
Mister, are
moment.
we supposed to be writing this down, right?
Yeah, definitely. For your own benefit, right? I'm not expecting you to turn this in, but you should write this down so that you have reference for the homework tonight, right? Notes are always what you need to be able to be successful, right? So notes help you remember what it is that you've learned. Now, obviously, since I'm recording this lesson, you can obviously come back and look at the lesson and be able to take a look at the information from there. And since I am recording this, I am going to upload this to my YouTube channel. I'm sorry, were you done? Was everyone done working on that? All right, so let's look at our last one that we're going to cover together today. Mary made a 5th batch of cookies in 1/10 of an hour. How many batches of cookies can she make in 1 hour? So again, I want to look at this last question because the last question is going to tell me what my unit rate's going to look like. Batches of cookies in 1 hour. So that looks like batches per hour. What do you think? Does that, whoop, I'm so sorry. That looks like batches per hour. What do you think? Is that what that last question looks like, that we should, how we should set up our unit rate? Because that's always the important part about these, right? Is knowing what goes on top, what goes on the bottom, so that you can actually accurately come up with the answer. Batches in 1 hour, batches per hour. So let's take a look at what she did. It says here that she had 1/5 batch of cookies in 1/10 of an hour. So that means we're going to have 1/5 divided by 1/10, right? Which means I have 1/5 times 10 over 1. So what's the final answer about how many batches per hour? Correct, Sergio. Good job, bud. What is going to be my final answer? What's going to be the final number? Not quite, Caroline. Take a look at it again. You pulled out the wrong factor. I know you were doing it right, but you pulled out the wrong factor. I'd sure like to see some comments in the chat section. I can cross cancel here, right? Because I can take 5 out of both of those. And what I'm left with is 2 batches per hour. And you see down here, if I were to think of it like more like this, let's say I thought about it as, I said, well, let's look at it as a proportion, because that is another way to look at it. I'm looking for 1 hour here, right? And then some amount of batches. So I want to go from 1/10 hour to 1 hour. Here's the number of batches that I made in 1/10. So I'm going to do my butterfly. You guys remember doing the butterfly? Remember that last semester where we learned about that butterfly for doing the proportions all the time? So this tells me I've got 1/5, sorry, let me get rid of this. So we just got this sheet here. So this tells me I have 1/5 equals 1/10 x, right? I multiply both sides by 10 because that allows me to cross cancel here, right? And I get 10 over 5, which equals 2, because this means division, right? And 10 divided by 5 is 2. Questions on that? Caroline?
Okay, so if you go back to how you did it before,
Yeah,
why did you cross out the 5 and make it a 1 and then the
Because I'm-
10 a 2?
right, because I'm cross canceling, right? So when I had this like this, right? I can take a factor out of the bottom and take it out of the top as well. Remember when we were doing cross canceling before? So basically I divided this by 5 and I divided this by 5. So this becomes 1 and this became 2.
Oh, okay.
Remember doing the cross canceling earlier in the semester, early last semester?
Yeah.
Sort of. Remember, when we're looking at cross canceling, if I say something like 4/3 times 6/10, right? Now I could just multiply straight across and then start reducing it, right? But I can also see that 6 has a 3 in it, right? So I can take the 3 out of here and take the 3 out of here, right? Because really it looks like this after you've multiplied. Doesn't it really look like that when you multiply before you actually combine the numbers? So these numbers are really all part of the same fraction. So if I could take, I can take the same number out of the top and out of the bottom. So it's just that from here, we're doing that without doing this step of putting them all together in one fraction. Does that make more sense, Caroline?
Yeah.
Okay, good. Great. All right. You guys want to look at tonight's homework? Let's take a look at it. All right. We have 19 problems for tonight, which isn't that much. So they all kind of look the same as the stuff we were working on before, right? Ethan writes 1/6 of a page in 1/12 of a minute. So what does that look like? Well, so, and it wants to know how much time does it take to write a full page? So we're looking at minutes per page, right? Isn't that what the rate, what their unit rate is? Time per page, minutes per page. So we're going to go back to what we had, and we're going to put 1/12 on top because that was minutes, and we're going to put 1/6 on the bottom because that was the number of pages. Now, I can either do this by doing a division problem, or I can do it by making a proportion. Either way is fine, and they both basically are using the same math. But let's go ahead and do it like this: 1/12 divided by 1/6. So when I do that, I do my keep, change, flip, and I get 1/12 times 6/1, which is going to give me 6/12. And when I reduce that, I'm going to get 1/2. So I think you can see that these are not going to be long problems, right? They're going to be pretty easy to work out. It's just a question of pulling this stuff out right. Now, I did upload the answer keys, so it's a separate document. All right. I don't mind you having the answer keys, but make sure you use them to check your answers to make sure that you're getting it right. Don't be foolish and just use it to turn in the work, because that doesn't help you. It's not going to make you learn better. It's going to make you get a 25% instead of a 75%. I think you'd rather have the full points for the test, and so you can pass and all that sort of thing. Yes. Questions? Any questions, guys? All right, the second page of homework looks like this. So it's going to be a matching. So you're going to do the same kind of calculations, and then your answer is going to be somewhere over here. Now this one makes your life really easy because they made a mistake of leaving the units on. So you'll look down here, you'll find the one that's miles per hour, and you'll know that that's the answer for that one. So I guess you get a freebie on this one. All right. What do you guys think about this? Not too bad to work on, should be okay. Okay, so here's how I'm working with due dates, all right? So this assignment, let me stop sharing my screen. This assignment is going to be due on Wednesday. Here's my rationale. I've been thinking about this. So what we're going to do is, if I signed it on Monday, it's due Wednesday. What that means is that you'll work on it tonight and hopefully complete it. You can come tomorrow with questions, get those questions answered, and then still be able to turn it in the next day after you've gotten some questions answered, okay? What do you think? Does that make sense?